Today we're going to be looking at factorising the more difficult type of quadratics. So something like this, x squared plus, let's say, I don't know, 3x plus 2. You should be quite happy with factorising something like that. We're going to look at the more difficult type of quadratic now, where your coefficient on x squared, the number in front of x squared, isn't 1. So broadly speaking, this video is going to be split up into two parts. Fairly straightforward. We're just going to go through two examples. So obviously part 1 is going to be the first example, part 2 is going to be the second example. Alright, so the first one we're going to look at is this 6x squared plus x minus 2. And as far as factorising these more difficult types of quadratics is concerned, your steps, they are fairly regimented. So if you look at the side of the screen, those are the complete list of steps, and we're going to go through one by one. Obviously, full notes are available on my website at idktuition.com, and it does explore this in a little bit more detail. But okay, so step 1. If you look at my quadratic here, I have 6x squared plus x minus 2. So if you're comparing this to the general form of a quadratic, ax squared plus bx plus c, you can see here that my a is 6, my c is minus 2. Right, step number 1, we need to work out what AC is. So AC is clearly just going to be minus 12. And now we've done that, step number 2, we need to find two numbers which multiplied together gives me minus 12 and added together gives us our coefficient on B, i.e. our number term. So we need two numbers multiplied together to give us minus 12. Added together is going to give us plus 1. Might take you a few seconds to work that out, but what we're looking for is this. So we're going to have plus 4 and minus 3. So this is step 2 complete. These two numbers here multiplied together, they do indeed give me minus 12. Added together, they do give me my coefficient on x, which is just 1. So added together, they do give me 1. Step number 3, we need to rewrite our original equation using, our original expression using this information. So your quadratic term stays the same, and all we're doing is rewriting this middle term, our term in x, using this information here. So what happens is we get this. Okay, so you notice this is exactly the same as this one here, because plus 4x minus 3x does just give me plus 1x altogether. So these expressions are the same. All we're doing is splitting up this x into our two separate x terms using these numbers here. Just a quick note on this, I will prove this later on in the video, but it doesn't matter whether you write this as 6x squared plus 4x minus 3x minus 2, or whether you write it like this, and you put your minus 3 first. Obviously, your signs need to be correct. Okay, step number 4 now. We're going to factorise our first two terms here, our second two terms here. So if we're just looking at these first two terms here, I want to take out the biggest common factor out of the both. In this case, it's going to be 2x. Now I'm going to have what times by 2x gives me 6x squared, which is 3x. What times by 2x gives me plus 4x. It's going to be plus 2. Now here, I'm going to do the same for these two terms here, but as you can probably see, we're not going to have, there is essentially not really a common factor to both of these. But if your first sign is negative here, what you're going to do is essentially take out a factor of minus 1. Okay, so minus, there will be a 1 here. What's going to go in here? What times by minus 1 gives me minus 3x, which is positive 3x. What times by minus 1 gives me minus 2, well, it's going to be plus 2. Now if you look here, I have, in this first block here, I have a 3x plus 2, and in this second block here, I also have a 3x plus 2. What you can do is take out a common factor to both of those two blocks. Okay, what times by 3x plus 2 gives me this first block here where it's 2x. What times by 3x plus 2 gives me this block here. And remember there's a minus 1 there. So your minus 1 goes in there. And that is fully factorised. And just to double check that this expression here is equivalent to this expression here, I can multiply them out. So 3x times by 2x gives me 6x squared. 3x times by minus 1 gives me minus 3x. Plus 2 times by plus 2x gives me plus 4x. Plus 2 times by minus 1 gives me minus 2. Okay, that is largely the same as that one there, and it does indeed give me this original expression there. So just to prove that this same method would work if I rewrote it. So in step number 3, I rewrote my expression like this, with my minus 3x first, rather than my 4x, will actually give me the same result. So again, I'm going to take out the biggest common factor here. So in this case, it's now going to be 3x. I'm going to have 2x here, minus 1 here. Now, looking at this second this second lot of two terms here, I can take out plus 2. And I'm going to have 2x and minus 1 in this set of brackets. And now I've got 2x minus 1 here, 2x minus 1 here. Can take out that common factor from both of those two blocks, and I'm left with 3x plus 2 in there. So it does give me the same thing there. If you wait after the jump, I'll go through one more example, and then hopefully I strongly recommend that you kind of go through the question as I'm doing it, because hopefully this should all start to become embedded in your mind. Example number 2 now. So we're going to look at this quadratic here, 12x squared plus 5x minus 2. Remember, step 1, we need to work out our A and our C. So in this case, A is clearly 12, C is minus 2. So AC is going to equal minus 24. So that's step 1, work out AC. Now we've found out AC, we're looking for two numbers multiplied together, which gives me minus 24, our AC, and added together gives me my B. Again, this might take you a little bit of time, maybe a few seconds to work out. I've got it written down in front of me. Two numbers are going to be 8 and minus 3. You multiply those together, they do indeed give you minus 24. Added together, they do indeed give you plus 5. Okay, so next step number 3, we need to rewrite this, or in particular rewrite these two middle terms using our two numbers here. So 12x squared, and just remember, it doesn't matter whether I write this as like this, so plus 8x minus 3x minus 2, or I do it the other way around and I have 12x squared minus 3x plus 8x minus 2. In other words, just swapping those two over. Exactly the same. It's going to get you to the same end result. Now, focusing on these first two terms here, taking out the biggest common factor, in this case it's going to be 4x. What times by 4x gives me 12x squared? What was 3x? What times by 4x gives me plus 8x? It's plus 2. Now here, again, you can see that we don't have a true common factor, so to speak, to take out of these two terms here, but because this first term does start with a negative, I'm just going to take out essentially a factor of minus 1. And all that happens here is that the sign on each of those final two terms is going to change, and then that does indeed ensure that I have excuse me, a term within each of these blocks that is common. Okay, so you notice I've got a 3x plus 2 here, 3x plus 2 here, and obviously going to take out that as my factor. Okay, taking out 3x plus 2 from this one, how do I get back to this first block here? Just multiplying by 4x. And then looking at this one, how do I get back to this block? Well, I multiply by minus 1. Okay, so just expanding this out to prove that it is the same as our original expression. So I've got 3x times by 4x giving me 12x squared. 3x times by minus 1 gives me minus 3x. plus 2 times by 4x plus 8x, and then plus 2 times by minus 1 does give me minus 2 there. Notice those two terms, they do simplify to give me plus 5x, so this is the same as that original expression there. And you notice it's the same as this line of working here anyway, so you can tell that that is correct. So there's one thing you need to be aware of when you're factorising this more difficult type of quadratic where the number in front of your x squared isn't 1, so you've got something like 5x squared or maybe 7x squared. And that is that there might be more than one different way of factorising that expression. So if you take a look at this one here, 12x squared minus 6x minus 6. So if we follow our normal rules, so first of all we need to find AC, so in this case A is 12, B is minus 6, and C is also minus 6. Our AC here is minus 72. Okay, step number 2, we need two numbers multiplied together, which gives me minus 72. Added together gives us our coefficient on x, so minus 6, which is our number for B, don't forget. So, not particularly easy this one, but combination is minus 12 and 6. I guess the clue was in the question really. So multiply those together, they do indeed give you minus 72. Add them together, they do indeed give you minus 6. So just going to rewrite our expression up here, incorporating that information. So it's going to be minus 12x plus 6x minus 6. And just notice here, of course, you could write this, you could switch these two terms around. Now moving on to the next step, we need to factorise our first two terms and then our second two terms. So clearly you can see 12x is common to both of these two first terms here, leaving me with x minus 1 in the brackets. And then outside I've got 6, common to both of those two terms, leaving me with x minus 1 here to get to my second block. And you know you've done this correctly because you have x minus 1 here and x minus 1 here. And to take that out, okay, how do I get from x minus 1 to this first block here? Well, I need to multiply it by 12x. How do I get from this x minus 1 here to this second block here? I need to multiply it by positive 6. Okay, so this is my factorised form here. But if you notice in the second bracket, I actually have a common factor that I can take out of each of these two terms. So I can either take out 3 or I can take out 6. Let's take a look at what happens when I take out a factor of 3 to begin with. Okay, so I'm just going to leave that there. Okay, so I'm going to bring it out to the front. So essentially I'm taking out a factor of 3 from this. I'm putting it at the front of the brackets, which is what I've done here. So essentially dividing each of the terms in this bracket by 3 leaves me with 4x plus 2. Okay, and just to verify, so what happens now if I were to combine, if I were to expand this first set of brackets, in other words, just incorporating that 3 into that set of brackets, 3x minus 3 there, 4x plus 2. So when we expand this out, you'd expect us to get back to that original expression there. So 3 to x times by 4x does indeed give me 12x squared. 3x times by plus 2 plus 6x. Now working on the second term, minus 3 times by 4x minus 12x, and then minus 3 times by plus 2 minus 6, okay, which does give me this original expression up here. Okay, so if you notice, I can factorise this original expression. This is in fully factorised form, and so is this. Okay, so more than one way of factorising the same expression. Okay, so we looked at the case where the common factor that we pull out at the front is going to be 3. What happens when we pull out 6 as our common factor? Well, pulling out 6 to begin with, so I need to divide each of these terms in the second bracket by 6. Leaves me with 2x plus 2, or sorry, plus 1 rather. Okay, and then expanding this first set of brackets, incorporating that 6 into the first set of brackets, I get that. Obviously that stays the same. So again, when you expand this out, 12x squared plus 6x minus 12x minus 6, which does indeed give me our original expression there. So we've looked at one quadratic expression, and we've looked at 3 different ways in which it will actually factorise. So the important thing to bear in mind here is that it's quite rare that you'll be required to factorise a difficult quadratic expression like this without having to solve an equation afterwards. And if you're factorising a quadratic expression as part of the solving of an equation, then it doesn't matter whether you factorise it in this form here or if you factorise it in one of the other 2 forms that we've looked at down here. You will get to the same solutions for x. But I mean, that's definitely something that you should be bearing in mind as you're going through exercises in class. Sometimes you may have a factorised form in the answers in the textbook which don't match your factorised form in your written solutions that you've arrived at yourself. Just bear in mind that what's probably happened there is that you have a common factor common to each of the terms within one set of your brackets, and if you were to take that term out, stick it at the front and incorporate it into the other set of brackets, you probably can get to the answers that are in the textbook. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.